All right, we're pretty close to being done with chapter 6. We left off on a slide that said return statement within a loop. Their note here is that in the interest of maintainability, you should use restraint when considering the use of a return statement inside of a loop. Generally the proper, well, I won't say proper, recommended way for structuring code is if you have some kind of method coming up, right, and don't type any of this stuff, and it's supposed to do something, right, you check for error conditions first. You try to make sure that everything that it needs are already set up. And then if you have a loop in here, you know, some kind of loop, a while loop or whatever, you don't have ways of escaping out of the code tucked inside the loop, because the loop could be several hundred lines of code long, right? There may be all sorts of stuff going on here, right, and if statements and whatever, and it may be really hard to find those statements, you know, and then down here at the bottom, you know, whatever you were supposed to do. A better thing to do would be to create a variable to hold your return value, set the value, and then break. Now, there's nothing wrong with doing this. It's just easier to follow the logic if there's really only a couple ways out. That there's some ways out at the beginning during error conditions, and that there's some ways out during the end. Now, if arranging it like that seems to make the code more difficult to follow, go ahead and do it like this. It's just that there probably would be better served if you had something that looked like this, where you declared a return variable, just going to call it R, right? Maybe -1 if it's an error state. And then you set R equal to 0, and then you broke out of your loop right there, because that's what you needed to do. And then here, under a different return position, you did R is equal to 1, and you broke out of it there. And down here at the bottom, you could return R. It's just kind of a more, that's a recommended way of doing it. Putting the return statement introduces a loop termination that's not in one of the standard places, up at the top or the bottom. For example, in the grow method 2 slides ago, the return statement is hidden inside an if statement that's embedded in a while loop. So we really shouldn't have done that. If we'd been a little bit more of a clever programmer when we wrote this. Where's that grow method? I'm not seeing what they're talking about, but whatever. So the default value for a local variable is garbage. It's not an insult. It's just saying that if you have a variable that's declared inside of a loop, of a method, right? You have some kind of a method and you declare a variable in it, it's local to that method. And if you try to print it out or to use it as part of an equation, the compiler is going to catch it and say that won't work. Now, the C++ compiler is not so kind. It might flag that as a warning, but it's not going to flag that necessarily as an error. The Java compiler absolutely would not compile here because he doesn't have any value. He doesn't have an assigned value. On the other hand, if you create a variable and it's part of the class rather than it's part of the method, right? If it looks like this, more like this, if you put any variables here, they get a default value of 0. Right, so they're not garbage. They're just initialized with 0. I don't know why they made the difference. I don't know why they didn't cite every variable, you know, that didn't have an initialized value was either invalid, or why they didn't all get initialized with 0. But they didn't. I guess that's worth putting as a comment. I'm not really expecting you to type in all these little cryptic things like that. Why would you have typed all that in? But this is certainly worth doing, right? Class members, instance variables, and class variables are initialized to 0 or false or null, depending upon their data type, if not given a value. Local variables have garbage values if not initialized. Code won't compile. if a variable is used without assigning it a value, if a local variable is used. So let's say initialize to 0 or false if Boolean, or null if an object type, a reference type. But those are all three versions of false, right? A null is a 0 in a sense, and a false is a 0 in a sense. You're lost. Come on. Oh, you're wrong. Let's see. All right, there we go. So local variables persist only for the duration of the method, within the curly braces in which they are defined. If way up here, this was an if statement, right, whatever, and we had some curly braces here and here, and we declared a variable inside that if block, and ZZ equals 3, right, we can't get a hold of ZZ down here. It's only valid from here to here. If you want ZZ to be accessible after that if statement, you better have declared it outside of the if statement. It's a local variable that's local only to the block of code that's subordinate to that if statement. Argument passing. Java uses pass by value, or pass by copy. Some people say it's pass by copy, pass by value. What does that mean? We may as well actually type some Java in. We haven't done that yet. Are we on Lecture D, as I suspect we are?
Yes.
So what we're going to do is we're going to write a function that accepts an argument, an int. The parameter variable is going to be called x, and it's going to try to change the value of x, and we're going to see if x actually gets changed in the driver code, in the calling code. So file, new project, Java application, Lecture D. Okay. So up here above void, I'm just going to write another function, another method. Public static void test parentheses int x in parentheses, and all it does is it tries to set x equal to a very identifiable number, 99. So down here we're going to declare a variable, and we're going to pass it in there, and we're going to see if it gets changed. Int a ge equals 0. Test parentheses age in parentheses. And if we print out age after this, what is it going to print? Is it going to print 0 or 99? Let's find out. System.out.println parentheses quote age equals end quote plus age. If this language was doing pass by reference, then when we called the test method, age would get passed in there, and x would be the same thing as age. And so when we changed x to 99, a would suddenly equal 99. It's passing by reference or passing by address. If I give you my address and then you change something at my house, well, my house has changed. But it's not. Java is passed by value or passed by copy, meaning that when we invoke this method, the value of age is copied into here. And so now x equals that variable, and any changes to it here don't affect this. It would be kind of be like if I wrote it like this. I don't really want you to write it like this because I'm going to rapidly undo these changes. Right? So if age was passed into a parameter, and then that parameter was copied into a brand new variable, why would a change to that have any effect on the parameter? And the answer is it wouldn't. So when it runs, it's not going to say 99, it's going to say 0. This is the way that Python works too. It says 0. In C++ and C#, there are ways of passing variables in, passing arguments in by address or by reference. But think about it. What if we had typed in test 33 there, which is legal syntax, right? Because it just wants an integer, right? Okay, x is now 33. It changes to 99. Is that 99 magically rewriting the value of 33? Is the universe now changed so that 33 is no longer 33, it's 99? No, can't do that, right? I mean, it wouldn't do it. So Java is pass by reference. Some people say pass by copy. A change to the value of the parameter does not change the argument that was passed in. It can get a little bit more subtle when the thing that you're passing in is a reference type. If you created an object called patient and you passed patient in as a reference type, you actually would be able to change the elements inside the patient object. You just wouldn't be able to create a brand new object and assign it. What if we really wanted age to equal 99 when we were done with this? We should have had a return statement. We could have done return x here, and then we could have done age equals test age, and when x got returned, it would get copied into age. So if you want to get some data passed back out of this method, a couple ways you could do it. One is you could declare a variable outside, a class variable, and both of them could access them, but that's really kind of lame. Or you could have a return statement. So specialized methods. Accessor methods are getters. We've been talking about getters since the first day, so I'm not going to talk about them. Mutators are setters. Access, you know what access means. You have access to it. Mutating is changing it. And then there are Boolean methods. A Boolean method is just something that returns a true or a false. We could write a function, a method, that would check that variable to see if it's even or not. Because until we do that, we can't even. All right, so here we go. Let's do public Boolean. Excuse me, it needs to be static because we're in a static context. You can only call other static methods when you're in a static method inside that same class. Public static Boolean is even. Parentheses int x. And we're just going to return parentheses x %2 equals 0 in parentheses semicolon. Now we could write it with 4 lines of code. This writes it in 1 line of code. I'm not trying to be too tricky. If we wanted to write it in 4 lines of code, it would look like this. If x modulus 2 equals 0, then return true, else return false. These both do the exact same thing. Why? Because this does this test, and this test right here returns true or false, which is why you're able to use it inside an if statement, right? So if x modulus 2 really is true, it's going to return true. Well, if that was the case, why didn't we just return the result of that calculation? So that's a one-liner that does the same thing as a 4-liner. But whatever. It's a Boolean function. So we could find out if x is even, and we could do something based on that, right? If is even, parentheses, age, in parentheses, then age plus plus, add 1 to age, for whatever. I mean, you know, this doesn't make sense. It's just showing the usage of it. What does %2 means? It means modulus. What does modulus mean? It means the remainder. So if we divide by 2 and the remainder is 0, then we're going to return true. Like 4 divided by 2, there's no remainder, so it would return true. 5 divided by 2, the remainder is not 0, so it would return false. Quiz questions. Which of the following is a data item in a class? Methods are not data. The public keyword is not data. An instance variable is certainly a data item. So if I ask this on an exam, certainly that would be the answer. And you'll have a quiz over this chapter, and it's not going to be quite... These quiz questions are always kind of lame. Which word is used? I mean, they're okay, but which word is used to create an object? Allocate? Well, we haven't seen any code with that. Create? No, we never saw any code with that either. New. Right, like we did, you know, point equals new point, or coordinate equals new coordinate, or whatever. Given this method call, what is the thing inside the parentheses? Somebody tell me. Okay, now these are really stupid answers, but that makes it real easy to guess which one's the right answer. What is speed?
An argument.
Yeah, it's an argument. Okay. And what's the formal name for a method like setAge that sets the value? Mutator. Okay, so I'll open up the Chapter 6 quiz, and please get it done within the week, and you can retake it as many times as you want to get an A on it. All right, but let's go to Chapter 7. Doesn't look right. So, Chapter 7. Additional details about objects. Let's start the chapter with a behind-the-scenes, detailed look at what happens when a program instantiates an object and stores its address. What happens? This declares a variable called car. So somewhere out in memory, we now have a memory address, and car contains that memory address, but it's not initialized to anything, so that memory address just contains 0. And then we say car is equal to new car. Well, that tells the system, the Java virtual machine, to ask the operating system for some memory. It creates the car object, and that is stored in the memory, and then the address for that is stored in the car variable. And then when we want to change a value of it, car.year equals 2014, this part tells Java to go to that particular address and then find that particular member of that particular object in that particular address, so it can be changed to 2014. And I could get up on the board and I could draw a lot about it, but I think I'm just going to leave it alone at that explanation right now. But here's our example. We have a variable named car. Now it has its own address, but it contains an address, which is 0 or null or not valid until it's allocated. And then when we say car is equal to new car, the operating system and the Java virtual machine go and allocate some space for that object. If you just had this code without that, it still works. That tells the operating system, go and allocate some memory and make a car out of it. And so it would. However, it's not stored anywhere, which wouldn't be of any use, most likely. So the address is then stored into the car variable, which is now 1062. And when it says car.year equals 2014, Java goes, okay, this car is located at memory address 1062, and it runs out to 1062, and it finds whichever address corresponds to that .year member. So assigning a reference. You could create multiple references to the same object, which can be confusing. But Like I could have two pieces of paper with my home address. Right? I can give one to Lindy, I can give one to Troy. You both have copies of my address. And then if you went and knocked out all my windows, when the other one of you went there, you'd find out that there was a house with knocked out windows, right? You have two addresses pointing to the same object. You have two street signs pointing to the same street. We could do that. Now, there's often no real reason to do that, but we could. So if we came up here and created just a silly, dummy little class, let's go back to using point, PT for point. And it's going to have an X and a Y value. Public int X comma Y, semicolon. So down here in main, yuck. You don't have to do this, but to keep the code all together on my screen, I'm going to cut this test function and this isEven function and put them below main. So all I'm doing is I'm cutting these, I'm coming down here, and before that last closing brace, I'm pasting that. So this is the end of the Lecture D class. Okay, you didn't have to do that. The reason I wanted to do it is so that as I was typing along, since I'm in main, right here, and I can see the class I'm about to use right here. So PT, P1 for point 1, equals new PT, parentheses in parentheses. That calls the constructor, the default constructor, to create a new object. We don't have to write the default constructor as long as we don't write a parameterized constructor. As soon as we add a parameterized constructor, we also have to add the default constructor if we want this code to work, if we want to be able to access it without putting in any arguments between the parentheses. All right, now we're going to make another object. Point P2 equals P1. Now they both have the address of that object in them. So any changes to P1 can be picked up through P2 and vice versa. So if I say P1.x equals 100, and then I print out P2.x, it's going to say it's 100. So I'm going to prove that. I'm going to add a system.out.println, quote, P2.x equals, end quote, comma, P2.x, except I've made a mistake. That comma syntax is Python. Sorry about that. Make it a plus sign. And when I run it, I'm going to see that P2.x is 100 because they're both pointing, they both have the same address in them. Two people with my house address, they can both get to my house. Both P1 and P2 have the same address, so when they run, there we go, right? P2 is 100 because we set P1.x equal to 100, but P1.x and P2x are pointing to the same object. They're not the same variable, right? It's two separate variables, but they both point to the same object. What if we didn't want that to happen? What if we didn't want that kind of copying to go on? Oh, this is the wrong file. No wonder I was starting to get confused. There we go, right? If we wanted P2 to be its own object, we better use a new statement. If we wanted P2 to be a copy of P1, we would need some additional code, which we could write. I'll see how we feel about it as we go on. But this is why you can't compare objects using equals equals. If I create two strings and I try to compare them with equal equal, there's no guarantee that it would work. Let me show you what I mean. String S1 equals Bob, end quote, semicolon. String S2 equals S1 plus Sam, end quote. And now we're going to check. We want to see if S2 equals Bob Sam. Should, right? Because S1 equals Bob, S2 equals S1 plus Sam, so it should say Bob Sam. We could prove it by printing it out. System.out.println parentheses S2 in parentheses. When it runs, we're going to see Bob Sam, no spaces. Great. So if I do an if statement to check, it ought to say that they're the same. If parentheses S2 equals quote Bob capitalized the same way as it was, SAM capitalized the same way it was, then I'm going to print out the word same. System.out.println parentheses quote same. End quote in parentheses semicolon. Else I'm going to print out different. So else, and these print statements can take a long time to type. There's absolutely nothing wrong with copying one of these print statements, pasting it, and then changing the text, right? So you see what we're doing. We've created a string that should equals Bob Sam, and so then we're going to check to see if it is equal to Bob Sam. And spoiler alert, it's not going to say that they're the same. See, it says they're different. Why the heck are they different? Because this equal, and by the way, this would work just fine in C++, because C++ does something a little bit differently than Java, and it would work fine in Python, because Python does something a little bit different than Java. But this one does not work. Why? Because S2 has an address in it. This Bob Sam has a different address, right? So they're not going to be the same. Even if S2 has an address that contains the word Bob Sam, it's not equal to that address. All this is doing is comparing two addresses. So what if I had a house and then my neighbor built an identical house? And we had two addresses, right? I lived on 101, my neighbor lived on 103. And then we checked if 101 equals 103. Well, they look exactly the same. They were built to be clones of each other, but it would still say that they're different because they're at different addresses. If you want to compare by content, not by address, and you almost never want to compare by address, here's how you really do it. But first we're going to make some changes to these print statement. We're going to say same value and different, same address and different address. Same address and different address. And then I'm going to copy and paste that, and I'm going to change the word address to value. But I'm going to have to make a change to the if statement as well. So I'm going to grab those 4 lines, copy them, come down here, paste them, right? But instead of doing this line, I'm replacing this line. So this time we're going to check by value. So I'm editing these words right here. I just changed those words address to value because we're modifying this if statement. And what this if statement is if S2 dot equals parentheses, quote, Bob Sam. You use dot equals to compare values. If you ever use equal and it manages to work, it's a miracle that it worked. Don't compare strings like that. Comparing other things is fine. Comparing, ints and floats and things like that, but not reference types. Any type that was declared from a class, any type that was declared with a capital letter like that, cannot be compared with equal. Instead, you would call dot equals. And when you write your own classes, you can write your own dot equals method so that we can compare 2 points, right? Is this point got the same values as the other point? So when I run it, it should say that they are different addresses, but they have the same value. That's what I want to see. I hope that's what I see. Yep, right. The string holds the word Bob Sam. It's a different address, but it's got the same value. Anybody got syntax errors or need more typing time? We all good? All righty. So this is just talking about the fact that you can have two references to the same object. They made a new car, and they made another car, and they just set a copy of it to that, and all it did is copy the same address. And so when they set the color of Stacy's car to peach, John's car, since it's the same thing, if you asked it for a color, would also say that it was peach. If you want two different objects, which you probably do, you would have to call new 2 different times. And if they were supposed to be copies, you would have to move the make value of one into the make value of the other, the year value of one into the year value of the other, and the color value from one into the color value of the other. So let's make a point that's a copy of one of these points. We already have p1.x equals 3, p1.y equals 4, and now we're going to make a new point and copy those values into it. p2.x, p2 equals new, capital P, t, parentheses in parentheses. Now we have a brand new object. And we can say that p2.x equals p1.x. We are copying those values into it. And p2.y equals p1.y. Now really we should make a method inside the point class that lets us make a copy like that, rather than just doing it like that. Because what if there were 20 variables attached to that class rather than just 2? Or each time that we go and add a new variable to our point class, we have to go and find every place in our code we were copying it to add that variable copy? No, we would want to make this code right here part of the class. We'll get around to that. Testing objects for equality. This is demonstrating the same thing. We have 2 cars. We set the color of both cars to red. We expect this equal statement to work, but it doesn't because each car is a different object, a different address. And all this does is compare addresses. So if we want to compare our points, we would have to add a dot equals method to our to our point. If we wanted to be able to do this, if p1 dot equals parentheses p2 in parentheses curly brace system dot out dot println quote p1 equals p2, we're going to have to go and write an dot equals method to support that. So we're going to go back to our point class and add a Boolean method. It's going to return true if all the x values match and all the y values match, and it's going to return false if they don't. So going up to the point class, this is not the total way that we would write an equals method once we become more sophisticated, but for our first shot, it's okay. Public Boolean equals, and it's going to take a point as its parameter. So inside the parentheses, pt, I'm just going to call it other, right? The other point. pt space other. So what are we going to do? If parentheses this dot x equals or not equals this dot x not equals other dot x in parentheses, return false. Or if you like, that can always go on the next line like that, right? In this one particular case, I like the way it looks when it's out on the same line. Next. y. Got to check our y values. This dot y not equals other dot y in parentheses, return false, right? We're going to keep seeing if they're wrong. And if nothing is different at the very end, we're going to return true because it passed all the tests. If we added a third value, if we added a z, x, y, x comma, y comma, z, we'd have to go and modify our equals method as well. We'd have to say if this dot z not equal other dot z. I wonder what you're... Nah. Do not make this change that it's suggesting. Yeah, I don't like the way that looks. It's valid, but I think this is easier to read. And sometimes being easier to read is better than being the most efficient. So now, since I'm calling dot equals correctly down here, and they do contain the same values, it should say that P1 equals P2. That's the message I'm expecting to see. But what if we change one of the values? Didn't mean to close there. What if we set P1 dot x equal to negative 900, right? Now they're no longer the same. Didn't mean to put an L there. P1 dot x equals negative 900. Now they're not the same, and so it's not going to print P1 equals P2. I'll probably delete that line because I'm not printing an else, so I wouldn't see a difference message. It's just that I'm not going to see it display that message, and it didn't, right? Okay, I'm going to get rid of that line. I like it saying that they're equals. It makes me feel good. So how did we get that to work? To compare our objects, we added an equals method to our class that returns false if any of the instance variables don't match. Never compare objects, parentheses, reference types, with equal equal. Always use dot equals, even if you have to write your own, which you do if it's the class you created. So never compare strings with equal equal. The only things you can compare with equal equal are primitive data types. What are your primitive data types? Use equal equal only for primitive data types, which are int, float, double, long, Boolean, char. All the things that have lowercase letters. If the data type does not begin in a lowercase letter, it's not a Boolean, it's not a primitive type. So passing references as arguments. When we pass a reference as an argument, like if we passed P1 or P2 as an argument, can we change the value of it? No, we can't change the value of it, but we can change the values of the members. So I'm going to go and I'm going to write some line of code here that changes the x value of one of these points. So public static void change underscore x parentheses, and we're going to pass in a point as an argument, so we better create a parameter variable that's a point, pt space, how about just p? Close parentheses, open curly brace, p dot x equals 9,999. And then I'm going to call it p1, wait, change underscore x parentheses p1 in parentheses. What's going on here? When this is called, it passes a copy of the value of p1. Now p1 is not an object, it's a reference, it's an address of an object. It passes that value into this variable named p. P is now a reference to the same object that p1 is locating, right? Now we have two addresses pointing to the same thing. We have two street signs pointing to the same street. So when we use that address to change something, it's also changed for that reference. So if we printed out p1.x, we would see 99999. We could prove that with yet another print statement. I wish there was an abbreviation, like typing in SOP. System.out.println parentheses quote p1.x now equals end quote plus, wait, put a space before that end quote, and then make after the end quote a plus p1.x. And it did, as predicted. But we can't change p itself. We can change the members of p, but we can't change p itself. What if I did this? What if I said, and I'm going to wind up deleting this line, p equals new pt, capital P, parentheses in parentheses, semicolon. And now when we change p.x to 99999, p1.x is not going to equal 99999. It's going to equal whatever it was up above. And see, p1.x still equals 3 from whatever earlier time we set it to 3, right? Because although we tried to change the value of p, we tried to create a new point and give p the address of that new point. Well, that worked here, but it did not actually change p1. p1 did not contain a new address. Now that's kind of subtle, and I don't really know how to explain it better than that. But if you use a reference as an argument, then that code can change members of that object, but it can't create a new object and assign it to it. If you wanted it to, again, you'd have to return a value. We could return this new point. I'm going to delete that line now since it breaks it up. And I guess I'll type that in as a comment. When a reference is passed in as an argument, the method can access or change the members of the object the reference points to. But the method can't create a new object and have that replace the original reference, unless you use a return statement to return the new object. So in a minute, I'm going to scroll back up and we're going to add a name to our PT class. I don't know why a point needs a name. The entire reason that I'm doing that is so that we can then have a comparison, right? We can add the comparison to the dot equals method for a string. because your homework is going to be to take one of your prior classes and add a dot equals method to it. Let's come up here, and inside our point class, we're going to have a string with a capital S, because it's a reference type, it's not a primitive, name equals, quote, double quote, point, end quote, semicolon. Now that needs to be one of the things we check inside here. And since it's a string, we can't use equal equal or not equal. Have to word it a little bit differently. If this dot name dot equals other dot name in parentheses equals equals false. I'm sorry it's such a long statement. Then return false. Now we could rewrite this so that we didn't have this equal equals false. How would I do that? I would just put an exclamation mark here. So I think I'll do that. I think I'm going to take this part out, this equal equals false out. Maybe it makes it clearer for you, in which case you could leave it like that. I don't know, is that clearer or less clear? Do you like the way it was worded before, Lindsay? Lindy, sorry. Or do you like the way it is now?
The way it is now, I guess. I don't know. They're but
Six-
equally.
6.5 and 1/2 a baker's dozen of the other. How about you, Shannon? I think I'm going to go back to the other way.
Yeah.
Yeah. I'm going to take away the exclamation mark and make that say false again. And that's okay. You'll notice it is putting a comment out here and it's offering to change it. Wow, why would it want to do that? That's dumb. All right, okay. So anyways, gonna leave that alone. I like the way it is now. The only reason I did that is just to show you how to compare the names of two things, because you're gonna need to add a dot equals method to one of the classes you've created in the past. And if your class has strings in it, then that's how you have to compare them. Now, why did I set it up like that? You could write one great big if statement that said if name equals other name and this dot x equals other name and this y equals other y, return true, else return false. But then your if statement gets longer and longer and longer and longer, and I like being able to do them one at a time. Just check each member one at a time. And then if we work our way through the entire object, if we've checked every member, then we can return true. I just think it makes for easier writing.
Makes it easier to read too.
I think so. So a swapping algorithm. I had a pseudocode fragment that swaps the contents of the x and the y variables. Well, fine, we can do that. And we can even put it in our code. So we have a variable named x, we have a variable named y. If you want to swap two values, I couldn't do this. I couldn't say x is equal to y and then follow that with, whoops, y is equal to x. Now pretend that they're capitalized correctly, right? Why is that not going to swap their values? Because when y gets copied into x, now they both equal 8. Neither one of them equals 3. We've lost that value. So you have to create a temporary variable. So what we would have to do would look more like this. T, fine, equals x, x equals y, y equals t, right? Because then you could copy in a temporary variable. Just like if you had an orange in each arm, and you needed to, or an apple in one and an orange in the other, and you needed to swap them, you can't, right? You know, you would just be mashing it. It wouldn't work. Instead, you have to add, you know, give one to somebody else, and then swap the other into the other hand, and then take it back from somebody else. That's the purpose of the temporary variable. So to swap two values, what am I doing? There, right? I hope that's what I had originally. Okay, so that's how you swap two values. Since I know that's an exam question, we're going to go ahead and put it in our code. So down in main, string in, or yeah, string in1 equals Bob, end quote, comma, in2 equals, quote, Sam, end quote, in parentheses, semicolon. Now let's swap them. We need a temporary variable. String temp equals n1, n1 equals n2, and n2 equals temp. Now what are you complaining about? The assigned value is never used. Yeah, so what? I don't care. All right, so what did we do last in our homework assignments? The book and the rectangle class, the improved book and the improved rectangle class. It'd be almost too easy to ask you just to add a dot equals method to the rectangle class because it looks so much like our point class. So I'm going to ask you to add a dot equals method to your book class instead. That'll be the homework. Tagging that up here at the top. Homework, add a dot equals method to your book class. Remember how to compare strings. Look at the dot equals method in our PT class in the notes for a reminder. And just to check it, right, your main code should create two books that are the same, that have the same values, and use dot equals to print a message that they are the same. And if your main is doing a whole bunch of other stuff because you keep modifying your old program, right, it's fine. Or if you feel like clearing all that out and only leaving the stuff about the books, that's also fine. So back to our things that you should always do when creating a class. Data private, methods public, that's one. Add getters and setters, that's another. Add constructors, if they make the class easier to use, that's another. And add dot equals method if you need to compare objects. It would also be good to create a copy method so that you could make a book that was a copy of the old book. But not going to do that. Not as part of today's homework. All right, I think that's about enough for today. So I think I'm going to stop the recorder. Well, we're getting out early. Oh no. Let's go a little bit further. I'm going to go and look at the PowerPoint. Let's take a look. All right, so the swapping algorithm. Ah, yeah, we may as well do this. Method called chaining. Now, we don't have hardly any methods that are worth using in our point class. I think I better leave this for next time. That's what we're going to do. That's where we're going to stop. All right.